All right, looking at problem G, we have A, where it intersects with A complement. All right, I'm just going to color this. I hope that before I color it, you have a prediction of how that is going to turn out. So first I'm coloring everything that is in A. Then I'm coloring everything that is not in A. A complement means all the stuff that's not in A. Color them a little tighter here so we can see everything happening. Okay, so now that makes sense, doesn't it? Because A is one thing, A complement is everything else. But what are we asked to find? Where they intersect. Well, do they intersect anywhere? No. That one is one thing and one is the other. There is no place where they will overlap. So what we do here is we define this as this or this, which would be the empty set. Okay. Technically, we should be making brackets around all of these answers as we go, so that this looks like a set that's defined with a beginning and an end. So I apologize for not saying that sooner. I've caught it now. All right, so there's all of our sets that we've defined so far. So this one here, A and A complement do not intersect anywhere, so there is nothing in that set. That is what we call the empty set. All right, and then H, now we're looking for A complement intersection C complement. So first we'll color A complement. So that's everything outside of A. All right, there it is. And then we'll do everything outside of C, the other direction, the other color. Okay, so there we go. There's A complement and C complement. I guess I could go right up to the border here. There, a little neater. All right, now we're asked to find where those overlap, which means the places where it's checkered. Okay, so where did I color both colors? It's basically the outside around the two circles. Okay, we talked about that earlier. So the part where it's checkered is all around the outside of the two circles. And that is the same as this. Okay, we'll talk about that in just a moment. So it's all the things that are outside both circles, which would be violet, green, and hamburger. So the set will contain green, violet, hamburger. Does it matter what order I write them in? Nope. Not at all. Okay. There's that. Now, it says here, 2 of the 8 sets above should be identical. This is no coincidence. It is, in fact, a law, one of 2, called DeMorgan's laws. So write an equation saying that these 2 sets are equal. So E, remember, was A union C, then complement. All right, and that is equal to that last set, which was A complement intersect C complement. Okay. Then it says the other of DeMorgan's laws is the same as this equation, except you change the unions to intersections and then the intersections to unions. So it would look like the A intersect C, if we took the complement of that, that would be A complement union C complement. And I'm looking here to see F is that A complement union C complement. So if we look at this one here, that was everything except the intersection, wasn't it? Now, if you look at what that original statement is, it's the intersection, but not. So you look at A intersect C and you take everything except that. If you look at F, that's exactly what that is. And the other way to get that same pattern is to take A complement and C complement and do a union of them. So there is the other of DeMorgan's laws. That's the second one. The first one was E and H matching. Okay, and there is our homework all finished.